Now that you know how to write the formulas for compounds and to name them, we want to look at percent composition. Percent composition is going to tell us something about the makeup of an individual compound. First of all, let's define percent composition. You're looking at relative amounts of every element that's in a given compound, and we're going to use percent by mass. So percent by mass means the parts out of the total in terms of grams. Now if you do percent composition problems correctly, all your percent should add up to 100. Percent composition a lot of times is useful when a scientist makes a compound and they're trying to decide if they've made something brand new or not. They'll do some analysis in percent composition to see if it matches up to anything else that's already known. Let's look at some example problems. Now this first one, if you have 8.2 grams of magnesium and you let that react with some oxygen, 5.4 grams to be exact, you're going to form a compound. And this question wants us to figure out the percent composition of both elements in that compound. Now if you remember the law of conservation of mass, this is pretty straightforward. Remember, the law of conservation of mass says that all the mass you start with in a reaction has to be accounted for in the end. So by knowing that, I know that I should have 13.6 grams of total mass in my final product. To find the percent of each element, I just take the grams that each element contributed to the reaction. So here's the magnesium. I started with 8.2 grams of it. That out of the total of 13.6 times 100 to make it a percent is 60.3%. Do the same thing with the oxygen. The 5.4 grams of oxygen that reacted out of 13.6 grams total mass times 100 to make it a percent is 39.7%. And just as a check, if you add those two percentages together, you do get 100%. So that's how you figure those out. Now here's a different kind of problem. Sometimes you'll just be given a formula for a compound and asked to find the percent composition. If you do, what you're going to need to calculate is find the mass of every element in the compound, like when you do molar mass, and divide it by the molar mass of that compound. Then multiply that decimal by 100 to make it a percent. Let me show you one. In this problem, you're being asked to calculate the percent of nitrogen and hydrogen in NH3, which is ammonia. So the first thing you need to know is the molar mass of that compound. I know that there's one nitrogen and the mass is 14 grams. I know there are 3 hydrogens. Each one is a mass of 1 gram, and I got that from the periodic table. So when I add all that together, I get a molar mass here of 17 grams for NH3. That's your total mass. Now out of that 17 grams, how much came from the nitrogen? Well, if you look at the math we just did, it's 14 grams. So the percent of nitrogen is 14 divided by 17 in terms of grams, and then you multiply by 100 to get 82.4%. Let's do the same thing with the hydrogen. Out of that total 17 grams of mass, how much of the 17 grams comes from the hydrogen? In the molar mass calculation, you see that it's 3 grams. So the percent hydrogen that's shown here is 3 out of 17 times 100 to make it a percent. You get 17.6%. Those 2% also add up to 100, so I think we did that correctly. Alright, one other type of problem. A lot of times you can use your percent composition to be like a conversion factor to find out the mass in a specific amount of a compound. Like here, we need to find out how much carbon is in 82 grams of propane. Well, the first thing I need to do again is to find the molar mass of propane. There are 3 carbons, each has a mass of 12 grams, and 8 hydrogens, each has a mass of 1 gram. That gives me a total of 44 grams per mole for propane. Now what I'm going to do is figure out the percent of carbon. 36 of those 44 grams came from carbon. So in propane, carbon is 81.8%. It's going to be 81.8% of propane no matter the size of the sample. Whether I have 82 grams or whether I have 8,000 grams, 81.8% of any sample of propane will be made up of carbon. By knowing that, I can figure out what is 81.8% of 82 grams. And when you work that out, you get a total of 67.1 grams of carbon. So that's how you use percent composition to solve for mass. I've shown you one example of several different types of problems. We'll work a lot more in class, and we'll do a lab on this too. So you'll get some more practice then. See you next time.